All right, we're in 6-6 here in Advanced Geometry. Today, we have more parallelogram talk. What do we know about our first problem here? Well, yeah. We got overhang, is what people said. What shape is this? Parallelogram. And you're right, there is overhang, so it's not really a polygon, but they're saying that this part of it is a parallelogram. We cool with that? Let's find x, y, and z. What do you want to find first? Let's find y, is what somebody said. What would y measure? 55 degrees. How's come? If that's a parallelogram, shouldn't opposite angles be congruent to each other? What do you want to find next? X. What you got for x? 125. How'd you get that? What do you know about these two right here? They got to be supplementary. Aren't those consecutive angles in a parallelogram? And any two consecutive angles are supplementary, correct? How about z? How's about z? How'd you get 55? You're saying we got alternate interior angles here? Like which ones? The y and the z? Are those alternate interior angles? Well, I need parallel lines to make sure that they're the same. Do I have parallel lines? This has to be parallel to this because it's a parallelogram, correct? So 55 degrees. Is there any other way we could have figured that out besides using that? Corresponding angles. Where are you saying we got corresponding angles? This 55 that was given to us and this z, are those corresponding angles? Are they both to the right of these green segments right here and above this guy right here? Well, these got to be parallel to each other, though, for that to work. Does this work? It's a parallelogram, right? Somebody was mentioned in the 360 stuff. I wouldn't do that at all. How much does this got to measure? It's got to measure 125 because aren't these opposite angles right here? And what kind of angles are these two right here? They're a linear pair, so you could have went that way also. Next! What do you want to find first? It's a parallelogram because they told us so. What do you want to find first? I think y would be the easiest one also, personally. You don't have to go there. How much does y got to be? 115 degrees. Notice how we're just putting these all in the picture, right? What do you want to find next? Z was a vote. X is a vote. How would you find x right now? These two whole things put together should add up to 180, right? So if you take 180, take away 115, and take away 31, you'd be left with that. That works. Let's try another way, easier way. If we find z first, it'd probably be easier, in my opinion. Just that's me talking. How can we find z like right away? Is this and this alternate interior angles? And being how these are parallel to each other, right? So how much has that got to be? 31 degrees. Cool. And now, whichever way you do it, you're still going to take 180 minus 115 minus 31 because I'm seeing this. What do y'all see right there? That's a triangle. Do you know two angles inside of it? Triangle is geometry's best friend, right? When stuck, look for triangles, right? You could have used the fact that these consecutive angles have to be supplementary also, but you all have to understand that it's this entire mammoth jamma right here and this one. So how much has that got to be? 34? Is that agreeable with everyone? 34 is what you want me to put, Dusty? Just 34? Okay. You all cool with those? Next one's weird questions till we get used to them. They say, must this be a parallelogram? Can this be a parallelogram? Then explain. It takes a little getting used to. Now we don't know if it's a parallelogram or not. Before we did, because they said so. This is a parallelogram. New set of instructions, new problems. It looks like a parallelogram. We don't know. We need to prove it. They're saying, must it be? That means, do you have enough information already to prove that this is a parallelogram? So let's answer that. You guys say yes? How come? You said we got corresponding angles, so let me do this. I'll just call this 1, 2, and 3 for simplicity. What are you talking about? 1 and 2 are corresponding angles, you guys feel? And are they congruent? So I put arc marks in them. That's what you need to do for me. What's so great about that? And which sides are parallel? Let me color. I got blues and I got reds. Which sides would be parallel to each other with these corresponding angles? Reds or blues? It's got to be the blues. How come? Because that's what the arc marks separately touch. Don't the arc marks separately touch the blue one, and the one that they're touching the same as is the red one, right? So these are parallel to each other. I'm down with that. Does that make that a that make that a parallelogram? No. So what else? Aren't these also corresponding angles, right? Aren't they both to the right of those red guys and above the blue one? And which set of sides would be parallel because of those corresponding angles that are congruent? So how many arrows? Must this be a parallelogram, yes or no? And since you say yes to must it be, the can it be means you say yes also. The only time you do something different on can it be is like if you say no to must it be, it means if you had like a little more information, like could it possibly be a parallelogram. But moral of the story is you said yes to this, you have to say yes to this. What's our explanation? What did we do to get those parallel lines? What did we have? Corresponding angles. What? Congruent. What else? Implies parallel lines. That's what we have. Y'all cool with that? That was a little too easy. It's like I still don't get the must it be, can it be explained part. Let's try the next one, see what we think. With that information provided, must that be a parallelogram? Well, I don't know. Maybe it can, maybe it can't. What do you see? What do we have given to us? These are consecutive angles, and they add up to 180. Aren't they supplementary? Well, I thought consecutive angles that are supplementary implies they have parallel lines. Isn't that true? So what's parallel? The greens or the blacks? The greens. Shouldn't this be parallel to that? We can prove that, right? What else? So let's do this, A, B, C, D, so you can talk to me a little more simpler. What else? Anything else? We could find B and C. Well, let's do it. Oh, after you have some more information. After you have some more. Are you all sure that the measure of angle B is not 72 degrees? It definitely could be, right? It definitely could be. Does it have to be 72 degrees? Does the measure of angle B have to be 72 degrees? Well, these are consecutive angles, correct? If this is 108, does this one have to be 72? To be a parallelogram, yeah. The only way that would have to happen is if these red ones were parallel to each other. Are the red ones parallel to each other? I don't know. So can we prove that this is a parallelogram? So must this be a parallelogram, yes or no? No. Can it be? Is it possible? Is it possible? Okay? So explain. What would we need to have for information? Let me try to say that sentence one more time. What kind of information would we need more of to make that a parallelogram? What would we need to know? Well, obviously, if you had parallel lines, it's going to be a parallelogram, right? But let's go back to the original picture. I'm not going to argue with you. You're right. It's like you're right. But is there what's the smallest bit of information you would still need in that picture to make sure that it has to be a parallelogram? Another angle measure, right? So if you had this angle measure, wouldn't that just be enough right there? And what would that one have to be? If that one was 72, we'd be in business, correct? Because that would force this one to be 108, because wouldn't all four of them have to add up to be 360, right? So don't we need one more angle measure, correct? So here's what we say. If opposite angles are congruent, we'd be good. But we don't have that. If opposite angles were congruent. And that's not the only thing you could write down there, but to me that's the simplest way to answer that question. You all cool with that? Now what if this was this? Let's start over. Pretend that we don't have that. Let's say that's 71 degrees. Must this be a parallelogram? Yes or no? Nope. Can it be a parallelogram? It's impossible. Why is it impossible? Because these opposite angles are not equal to each other. You with me on that? So you cool with must it be, can it be, explain problem. Next, let's find A, B, and C. Is this a parallelogram? Yay or nay? How do you know? Two pairs of parallel sides. This is a parallelogram because we got the two pairs of parallel sides. Let's find A, B, X, Y. Go for it. What do you want to find first? B? How much is B?
5.
What do you guys think? 5? You sure?
No. No, because they're not big biceps.
What's true about the diagonals of a parallelogram? So if this is 5, should that be 5?
Yeah.
Okay. I'm down with that. How about A? What about A? Make sure you put it in the picture. Guys, I'll tell you, that's the secret to these problems, putting that information in the picture. Be inside there's an answer blank. We'll also put it in the answer blank, but putting it in the picture is delicious. How about an X? Can we find an X? Interesting. Should it be 60 degrees? Here's X right now. Should it be 60 degrees? This is not a symmetry line, correct? So I would say no to that. What could we do to find X? (180 minus) Where'd you get 50 from? Isn't that 50 degrees right here? So this whole bad boy is 50 degrees, sorry. And this right here, right? Tell me about the green one and the red one together. Should be supplementary, right? So if you take 180 minus the 60 minus the 50, wouldn't you be left with that right there? Do that for me. This whole thing is 50 degrees. That means that this whole thing's got to be 130 degrees, honestly, you know? What'd you get? 70 degrees. Double check real quick. It's always good to add them all up and make sure it equals 180. So these two, isn't that 130? And this is 50, right? Doesn't that add up to be 180? Cool. How about Y? Y's up here. How much? 10? Why 10? Why 40? Right, aren't these right here alternate interior angles? And we've got these parallel lines, so good deal. That was a warm-up. Let's try another one. Is this a parallelogram? Yes or no? Why don't you pause the video, play around with it, and find as much as you can. So after messing around with it for a little while, today we've discovered for sure that A is 6 because the diagonals bisect each other in a parallelogram, and B is 13 because those are opposite sides, right, and they got to be equal to each other. What about X and Y? Anybody got those yet? So here's the thing you should do. Just because you might not be able to find X and Y right away, can you find anything else to like get the snowball rolling down the hill, kind of, sort of? What? I'll let you guys play around with that for a while. Let's get the thought process going to where maybe we wouldn't have saw that. 20 degrees, right here. Can we put a 20 anywhere else? This is a parallelogram. Can you put a 20 anywhere else?
Yeah.
Where at? Just tell me what like justification type thing you would use. Its alternate interior angle should be 20 degrees, right? Here's a 40. Can you do anything else? Shouldn't this be 40 degrees also? You with me on that? That's something hopefully you would have got without pushing too far. Then what did you say, Macy? First, slow down. Are there triangles in this picture? And here's our best friend, right? When stuck, look for triangles. Which triangle are you talking about? This one? Study that, guys. What do you see? Why is it isosceles? It's got two sides. It's a 6. Now let me ask you this question. If you don't put information in the picture, would you ever find that? There's no way. If you only put a 6 here, and you don't put the 6 here, you'll never see that that's an isosceles triangle. It's hard enough to see it when that 6 is in the picture. Do you see this side 6 and that side 6, right? So how does that help us? If I do this, if I call this, well, let's do Q, R, and T, where's the vertex of that isosceles triangle? Q, because isn't that where the 6's touch each other at, right? So how does that help? If this is 40 degrees, how much has that got to be? 40 degrees, because isosceles triangles imply that those base angles are congruent, correct? Can you find X now also? No calculator. Can you find X without a calculator? How much are these two? 80 degrees. What's X got to measure? 100 degrees. What a horrible looking picture. That's like an acute angle right there, but it's 100 degrees, right? Doesn't matter what it looks like. It's about the math behind it. I want to explain that uno mas times. We found the basics, correct? We put it in the picture. We got stumped. We looked at triangles. Booyah, booyah, isosceles triangle right there. We knew this is 40 because that was 40, and these are alternate interior angles. These are the base angles of that triangle, so they have to be the same B and how it's isosceles. Then with the triangle sum theorem, that's got to be 100 degrees. I like it. How about this bad boy? X and Y is what they want. Get it done. Shouldn't have any problems with this. Y, can I set these up to where 10 equals 2x plus 4 and 5y equals 15? Diagonals bisect each other. Awesome. Next. Find the value of x and y in the following parallelograms. Are these parallelograms? Of course they are. They told us so, and it's even marked in this particular problem. Right? What do I want to find first, x or y? Let's set up an equation to solve for x. Help me. What do you got? 3x minus 40 equals x, due to the fact that those are on the diagonals, and the diagonals bisect each other. I don't like taking this x over to the left side and getting a 0 there. I mean, you could do it. I just don't like it. I'd rather take this 3x over here. You with me on that? That's just me. But what would be left over there when I move that 3x over there? Negative 40 equals what? And then x would equal how much? 20. All right? 20. Y. Let's set up an equation for y. What you got for me? I'm going to do this. Some people said y plus 30 equals y squared. I'm going to do y squared equals y plus 30. You'll see why here shortly. First question for you. What don't you like about that? There's a squared and a first power in it at the same time. This is a quadratic equation, correct? To solve a quadratic equation, there are many methods. You could try to factor it. You could try to complete the square on it. You could use the quadratic formula, and even others that you'll learn about next year. What do you want to do? I'll tell you, you don't get an option. Let's factor it. How do you factor them? What has to happen first? Got to get it equal to 0. And if you can do this at the same time, keep the coefficient in front of the squared term 1, you'd be in business. So what would you like to do to get this equal to 0? Subtract this stuff over, right? Wouldn't y squared minus y minus 30 equal 0? So what do we got to do? If the idea of these being y's instead of x's scares you, don't let that scare you. It's just a variable, right? It's just like x squared minus x minus 30 equals 0, or b squared minus b minus 30 equals 0, or q squared minus q minus 30 equals 0. It's just a variable, right? So is the a value 1? Yes or no? Well, don't forget, we're doing ax squared plus bx plus c equals 0. This is standard form of a quadratic. Isn't a the number in front of x squared? Or in front of the squared term? What's the squared term here? What's the number in front of him? 1. Good. Our job is to do what, sophomores? numbers that multiply together to be negative 30 and add together to be negative 1. Find me those two numbers. 30, right? So what do you got for me? 5 and 6, but which one's got to be negative? The 6. Cool. This is an easily factorable situation. When the a value is 1, you don't have to do that frowny face situation. You just say it's going to be x plus 5 times x minus 6 equals 0, right? You break it up into the two binomials. It's like unfoiled. What? Thank you. It's y's, not x's. My bad. Y'all cool with that? So now that we've got it as two dudes times each other, we use the zero product property. Because isn't it a product? What does product mean mathematically? It's a multiplication problem of two guys, and it multiplies together to be 0, right? So what value of y would make this guy turn out to be 0? If y was negative 5. Or what value of y would make that turn out to be 0? If y was 6. Y'all cool with that? Now, what do you think about those two answers? Do they both work? Should we throw any of them out? What do you think? You want to throw out the negative 5? And why do you want to throw out the negative 5? You can't have a negative length, is what someone said, right? You can't have a negative length. Is this the length, this negative 5, is that the length of the diagonal? Yes or no? So what you have to do is you have to substitute those numbers back in to see what the length would turn out to be. And if I put negative 5 back in for y, right here, what would that turn out to be right there? What's negative 5 squared? Positive 25, right? Put negative 5 in right here, would you get negative 5 plus 30, which is positive 25? Is this a possible y value? Yeah. What about 6? Would 6 be a possible y value? Because if you substitute that again, you get 36 or 36. Isn't that possible also? So we got two different answers for y. Y could be negative 5 or 6. Sometimes they'll both work. Sometimes they won't both work. You have to substitute them back in to see if they work. Let's try again. Holy cow. Do we have a parallelogram on this bad boy? Yep. Let's see if we can set up some equations to solve for x and y. Who's got some ideas for me? X plus y equal 85? Everyone down with that? How come? Why should those be? Those are alternate interior angles, right? They got to be congruent. Awesome! Awesome. There's one equation. Time out. Do we need a system to solve? Yes or no? Yes. Will we end up doing any factoring on this? Are there any quadratic situations in there? Now we need a system, right? We got x and y, two different variables. So I need a whole other equation with x's and y's in it. What can we do? X minus y, what do you want to let that equal? Play around with it. Pause the video, play around with it. The suggestion of this x minus y equaling 110, here's the question. If you have parallel lines, you get alternate interior angles congruent, or you get corresponding angles congruent, correct? Is this x minus y and this 110 alternate interior angles? No. Not slow down, slow down. Let me finish this. Are these alternate interior angles, yes or no? They're on alternate sides of this, but it's like between the parallel lines, they're not even, this isn't even touching the parallel line. You with me on that? Are they corresponding angles? This also is not touching a parallel. This has nothing to do with the parallel lines. Y'all cool with that? Now what were you saying? X minus y equals 25 was a suggestion. I don't even have a 25 in this picture. Could you explain where that came from? Okay, so let me highlight that. They say, please check out this triangle with the 85. Let's stop for a second and realize we went to geometry's best friend again. Isn't geometry's best friend the triangle? The problem in that triangle is there's only one angle in it right now, an 85-degree angle. I could find another one. How can I find another one, Megan? This 110 and this angle right here are special. What's so special about those two? They're a what? Linear pair. If this is 110, this has got to be how much? 70 degrees. Cool. And now you have two angles inside of that triangle. Can you find the third angle? How much would that be? 25. Because all three have to add up to 180. Let's take a timeout and go over that one more time. They gave me this 110. I got to use it somehow. You could view this. Isn't this got to be 110 degrees right here because they're vertical angles and these are linear pairs, 70 and 70. You know, you could set it all up. But this is the one that really mattered to us because it's inside of this red triangle where you have an 85 and a 70, and the only missing angle right there is 25. And being how these are alternate interior angles, shouldn't x minus y equal 25? Daddy likes that one. Solve that system. Already opposite signs. So bye-bye y. You want to know something that I've seen over and over and over again? Mistake-wise, people think x plus x is x. What's x plus x? 2x, right? Watch out for that. X plus x is 2x. So shouldn't x equal 55, right? Yes? No? Maybe? Sub her back in. 55 plus the y equals 85. And y equals how much? The dirty 30. Which I passed 4 years ago. Yay for me. Uno mas. Set me some stuff up. Give me one equation. What's an equation you want right now? X squared equals 3x plus 4. What do y'all think about that? Should that be true or false? True. Now let's think about it. Do I need a system to solve this problem? Yes or no? No. Same variable. Base x each time. Well, I need to factor this problem. How come? It's quadratic, right? It's x to the second, x to the first in there also. Got to get it equal to how much? 0, baby. X squared minus a shui x minus a 4 equals 0. Then you got to ask yourself the magic question. Is the a value 1? Yes or no? Those are easily factorable. Find two numbers that multiply together to be c and add together to be b. Those two numbers, 1 and negative 4. So how about x plus 1? Maybe. X plus 1 times x minus 4 equals 0. I don't want us to get in a bad habit. The only reason that this was easily factorable is because of this. What was that reason again? A is 1. Remember, when it's not, you got to do that multiplication frowny face thing and find two numbers, split it up into a 4-banger, factor by grouping, all that stuff. What could x equal? Negative 1 or 4. Let's see if they both work. If x is negative 1, we want to see if we get a positive distance out of that. If we put negative 1 back in for x, will that turn out to be positive? Yes or no? Yep, that turns out to be positive 1, right? Because negative 1 squared. Will that also give you a positive 1? Negative 3 plus 4 is positive 1. So this checks, right? How about 4? Would 4 be an okay deal? Cool. Let's find y. Set up me an equation. Solve for y. Pause DOS video. Try it out. Here's my equation. Got my a value of 1. Got to get it equal to 0. Keep it in the right order. I got y squared first. What do you want to put next? Minus y. Minus equals 0. Two numbers. What are they? 2 and negative 3 or negative 2 and positive 3? Cool. So y plus 2, y minus 3 equals 0. Y'all cool with that? Solve. 0 product property. Y could equal negative 2 or 3. Are they both good answers? Can y be negative 2? We put it in right here. You'd get a negative 2 for that side length. Can't happen, right? So we cross him out. That's called an extraneous answer. It means it works algebraically. We get an algebra answer, but it does not work for this particular problem, so it's extraneous. Does 3 satisfy? Yep, so 3 is the only answer to that. Good?